So now in this video, we're going to look at the zener diode again. So this series of videos I'm making is focusing on voltages. And the zener diode is a great component for that because when there is current running through it, as long as the voltage is higher than the zener diode's rated voltage, you're going to have the zener voltage across the diode as long as current's flowing through. So use the zener diode reverse bias, unlike a rectifier diode, which when you want it to conduct, you use forward bias. And in any case, we're going to use a 5.1 volt zener diode to set the current through it, and a bit for the transistor. We're going to use a 1 kilo ohm resistor there. So the transistor here, this is an NPN bipolar junction transistor, the 2N2222, and maybe the most well-known one. And any NPN bipolar junction transistor should work though, but it may have a different pin layout. But if it starts with 2N and nothing before the 2N, it probably has this same pin layout. We'll look at that closer. Now at the emitter, we have an emitter resistor, 1 kilo ohm again, and exact value, not terribly important, 10 kilo ohm may work just fine, but I have a 1 kilo ohm going from emitter to ground. That helps hold that voltage there even as the load changes. Sometimes you can get away without it, but it's a good idea to have that there, just to make sure. I think I only had one circuit so far where I absolutely needed it. But in any case, then we have a load. We have a switch and a 220 ohm resistor. So 1 kilo ohm, 1 kilo ohm, 220 ohms to protect the LED, red LED here, from 5 volts. So the cathode, again, this is a diode. We got forward biased so that it lights up when I close the switch. Cathode to the negative side. That's the shorter lead, long lead the anode, connected to the resistor. The main takeaway though is that the voltage across the load should be the zener voltage. That's why we're using the transistor to help transfer that voltage to a load. With the NPN bipolar junction transistor though, so it can provide the current, because as current through the zener diode changes, it can throw off its zener voltage. If it gets low enough, it won't even be the zener voltage. So this will transfer the voltage, but we'll lose that base to emitter diode drop there. So it's going to be about 0.6 volts. So all this stuff is going to be approximate. That's a 5.1 volt zener diode. It'll shift a little with how much current is going through it, and same with the base to emitter of the transistor. So we're not looking at exact numbers here. I haven't even measured them yet, but we should be really close with our estimates. So now in this series, I'm using almost exclusively the oscilloscope to look at the voltages. So you can see here we got 9 volts at the supply. Of course, we have the transistor is basically always on, so it's always outputting the about 5.1 volts approximately, and putting the current through the resistor. So even though the LED is not lit, that resistor is passing current. Let's press the button, make sure we're not getting to 20 milliamps. Alright, we are getting 20 milliamps, so I'm going to raise that to 30 milliamps right there. And looks like 20 milliamps will be the current going through that resistor and through the load. Now, this is not up 9 squares, even though I have the alligator clips from the oscilloscope going to these jumpers, and we're done with the power supply. We'll zoom in. I have them clipped to jumpers, and then I put them into the breadboard right there. So we're measuring the breadboard power supply. As you can see here, each square is 2 volts right there. So we got 2, 4, 6, 8, and then 9. If I change it to 1, which I'm going to do, it's going to go off the top there. Now we have the, so it's about 1 square above what we can see. But the rest of our voltages are going to be lower. So we're going to zoom in. You can see we got the transistor here. So it's the 2N2222. I've gone over it a lot, so I'm just going to quickly summarize. The top pin with the flat side to the right, we got the collector. In the middle is the base, and then at the bottom is the emitter. And that's connected to the top of the switch, which comes across here to that resistor there, the emitter resistor. This resistor going to the LED is down 1 spot. So the top 2 pins are always connected, bottom 2 are always connected. When you press the button, all 4 of them connect together. And so we got the current limiting resistor going to the base, and then it's going to the cathode of the zener diode, and the anode, remember you use this reverse bias to get the zener voltage, is going to the negative rail. right there. And we can zoom back and we can look at that voltage. So we're going to go to the node where the base, the middle pin of the transistor, the resistor, and the zener diode connect. I'm just going to go to the other side. So it's one spot above the switch there. And there you can see at the base we have 5 volts right there. So if we used a lower value resistor here, there'd be more current flow and it would raise a little bit more. But in case it's 5 volts, that's plenty good. So it's just slightly with current, as long as you got enough current to get the zener voltage going. So now we can go down to the emitter. So that connects to that resistor along the top there. It doesn't matter if we go here, it's all one node. There you can see we got 4 and looks like about 0.2 right there. And so we had the about 5 and it took off about 0.6 volts because we have the base to emitter drop. The main thing is though, you can see we got 4 and I don't know, maybe that's 0.3 right there. But we can look at where that is, come down here to the bottom of the switch, and before it scrolls off, I press the button again, and you can see that even though we changed the load significantly, it held steady. It held that same point. So that's at the resistor and the LED, the load. This is directly to the emitter resistor. That helps hold that voltage there. So we looked at the zener diode powering the load directly, and you could, if you had a low enough value resistor, do that. You could get a voltage there. But in this case, we have basically a certain amount of current for the most part going through the resistor and the zener, and it's also going through that resistor. But the transistor is the main component, putting the current through that resistor, and then the load. So it provides current from the power supply as needed from the jumper there to hold that voltage there. That's why it's going to be a lot more steady than the zener diode alone. The zener diode, for the most part, is just telling the base of the transistor the voltage it wants. You're losing a little bit from base to emitter, about 0.6 volts, but for the most part, other than that, it transfers really nicely and holds really steadily. So, hope that all made sense, and I'll pop up some other videos. Make sure you check them out. Click like, subscribe, the bell, and all that. Check out all the links I put in the description. Donate to Patreon if you can. That would help out a ton. But watching my videos or whatnot, that all helps a lot too, so thanks for that. I'll see you in the next video.